Is the presentation visible?
Yes, sir, it is visible.
So first, apologies again for the wrong diagram that I had in the class yesterday. So I have corrected and also somewhat elaborated it. So this is the LMS use case basic diagram we are talking about. So if we look at, we have three human actors: executive, lead is a executive, and manager is a lead. That is quite obvious. And we have two non-human uh, mm, actors. I've included sysadmin now, printer and sysadmin. So an executive can do a number of use cases: recording attendance, joining, requesting leave, canceling leave, availing leave, and so on. Lead is a executive, so lead certainly can do anything that executive can do, and the additional use cases are approval, revocation, and export of the lead. Similarly, manager can do whatever lead can do, and few additional debit, credit, hiring employees, firing employees, and so on. And in between, we can see that we have an export of leave for the lead, which is a specialization of export of leave for the executive. So use cases can also be generalized and specialized. Similarly, you have it for the manager. Printer is a passive actor in these export processes. Actually, there should be a dotted line between export lead, leave, and printer is optional, because you have this dotted line with the export executive leave. Anyway, sysadmin can actually, sysadmin, as we say, is a batch job, a cron job. So sysadmin performs the use case of a batch job, and there are a variety of specialized batch jobs which are specialized here: daily job, monthly job, quarterly job, and so on. So this is a basic use case diagram, and then we will do some refinement to show the include relationships. So here, instead of cluttering the same diagram, we are including it in a separate diagram. So for inclusion relationship, we have some additional use cases like validate leave. Now, this validate leave use case is not what directly executive or someone will use. But if you request for a leave, then that leave will need to be validated. Right? So every request for a leave will include this use case of validate. It has to validate, and then only the request can be processed. Similarly, the leave status is another internal use case which will be included in revocation, cancellation. Once the leave is availed, then a deduct leave will be a use case, which is will again in turn include. So you can say there can be multi-level include also. In turn will include current leave balance, because if you deduct leave, then the balance will change. And current leave balance is also included in debit. It's also included in credit, and so on. Right. So you can easily see these are. If you mentally think in terms of C++ model, then these are kind of overriding of functionalities. The other extension that you can do is extends relationship. So extends is, suppose if you consider approved leave. So approved leave has a standard process. Right? It will check the leave type. It will check the leaf balance, and accordingly, the lead can approve the leaf. But there are some types of leaves. There are some conditions for which additional checks are required. Right? So those condition points are called extension points. For example, if it is a maternity leave or if it is a sick leave, then the medical report needs to be checked. If it's a parental leave, then the parental certificate needs to be checked. So this says that the use case has a way of doing things, but on specific extension points, specific conditions, an additional use case will have to be executed. So this is different from the include. In include, you do that included use case for every instance of the use case which is including it. But here it is conditional and based on the particular extension point, particular condition type, and the use cases could be different. So this is the notion of extend. So you can see that a lot of things which were spoken about in terms of the specification document has now at a level been captured in terms of simple diagrams. So I just wanted to revisit this diagram. So with that, let me go back and share the UML diagram discussion. So this is what we started discussing. We'll do a quick recap that UML is a unified modeling language, and we have understood the basic requirement for UML because you need a standardization to communicate between the team as well as with the client. And that representation needs to be consistent, accurate, particularly with reference to software design analysis, precise, and so on. So primarily an annotated graphical language is what is adopted for. So UML provides the user with an expressive modeling language. That is the basic purpose. And it has a number of ready-to-use core concepts. So you can just they are defined. You just need to apply them to your situation. It also provides for a formal basis and integrates the best practices. It is primarily targeted towards being open, so it is not professing any specific process, modeling tool, or modeling guideline, or a programming language. For example, in this LMS, I've always been referring to C++ as a vehicle, but it's not necessary from this UML. You can actually make use of any other suitable language like Java to actually implement the LMS system. And we have seen the evolution of UML. What we will refer to is UML 2.5. So for UML 2.5, there is an official website of the OMG, and we will frequently refer to that website. So there are various diagrams in UML. Okay? So this is kind of a class diagram of UML diagrams. So this is UML in UML, let's say. So at the root, you have all UML 2.5 diagrams. And what we show in these boxes are different types of categories of diagrams that exist in this 2.5 standard. You can see that some of these diagrams are written in black and some are written in blue. So the black ones are kind of older diagrams. They are more established and coming from, you know, UML point 0.9 typically and so on. And the blue ones are kind of extensions that are happening. Right? So the blue ones you will see typically are specializations of other diagrams. Okay. Now the basic classification of the diagrams fall in two categories. One is there are structural diagrams that show the static structure of the system and its different parts in the abstraction. Right? And that structural diagram may not be at one level, it could be at multiple levels. More and more refinements could come in. So structural diagram would tell you, for example, if I look back, the class diagram itself is a structural diagram. Right? It will tell you what are the classes, what are their members, data, what are their methods, what is the access mechanism for them, the visibility, and so on and so forth. Similarly, the object diagram will tell you when you instantiate objects from a particular class, then how that object will be structured, what will be the layout, so on and so forth. So on the left, the structure, all that you see are primarily talking about the structural aspect of the system. Whereas what you see on the right, the behavioral diagram, talks about the dynamics of the system. Right? It talks about the dynamic behavior of the system. So it describes how over time changes happen to the system. Right? So the direct involvement of time may or may not be there in a behavioral diagram. Like you have a use case diagram, which I have already exposed you to, where you're talking about, who activates what, responds to what, what are the different ways your system will be used and so on. Though it does not talk about the temporal aspect, but it talks about how the system should behave at the topmost level. Right? So that is a behavioral diagram. And then there are several, behavioral diagrams. For example, the other behavioral diagram is activity diagram. Activity diagram tells you what are the different activities that will go on. So again, you will see many of these will actually be a refinement of the use case diagram. Use cases are just abstract. It's saying that I want to apply for it. That's my use case. But that does not tell me what kind of actions I have to take, what is envisaged in this application process and so on. So those are detailed more in the activity diagram. What are the activities that will happen and so on. State machine diagram is a kind of is in form of a state chart. I mean, state machine you already know, right? You know the FSM, finite state machine. So the state machine diagram tries to capture the state information of the system. Right? We say that the system typically and will go through a number of states, and a state will define kind of what activities can be done, and based on that activity, what transition will happen in terms of the state. For example, you want to say apply for a leave. Now, if you are at the initial state of the system, then certainly you will need to, before performing Am I audible now? Hello?
Yes, sir. Yes, sir.
I'd lost the connection, so I'm getting back. It's always a problem. Okay, so here is the presentation. So as I was saying that in terms of the state machine, when you're in the initial state, obviously you cannot apply for a leave or do anything unless you log in. But login typically is not captured in the use case diagram because that is not an, that is not an intended use case for the user. You would not say that I want the leave management system to be built because I want to log in. Right? No, but this is a necessary requirement for the system. So even though use case diagram will not have it, the activity diagram will have activity like login, activity like authentication of the user, activity like creation of new user, and so on and so forth, right? So the state machine, in terms of the state machine, from a very initial state, when you log in, you come to a different state, right? So that is a logged in. You are not logged in state to you come to a logged in state, and there will be attributes for that because the logged in state has the state, it has the user, user ID, it has the specific user attributes and so on, and how the system travels through the different states is what is represented by the state machine diagram. It is, as I said, conceptually, it is like a finite state machine, but we will see in actual UML reality, there will be more details that are involved. Was there any question?
Sir, actually, I guess your screen isn't shared. You cannot see it.
Yes, sir. We
I,
cannot see your screen.
Sir, it's not visible.
I have shared, but
So try it once more, please.
yeah, I'm trying to do it. I have shared. Can you see it now?
No,
Is
sir.
that no? You cannot. Oh my
No,
God.
sir.
So I'll just log out and log in again. Some days the system is in bad mood. Just wait for a minute. I'll just log out and come back.
Professor PPD, you are not audible. Actually, I am not able to hear. I don't know. Maybe you can restart the software. Sometimes Microsoft Teams software creates some problem also. Are others able to hear me?
Yes, sir. Yes, sir.
Okay.
Am I audible now?
Yes, yes, you are audible.
I don't know what's
Audible.
wrong today. Is the presentation visible?
Not yet, but
So it is loading. Yes, sir, it's visible now.
Oh my God. So I was talking about the state machine diagram. So this is, as I explained, this is going to be a finite state machine, but with different annotations as we'll see. In terms of the behavior, very important class of diagrams are interaction diagrams, right? So interaction diagram by the name itself is not a separate diagram. Rather, it is a placeholder for the other specialized diagrams which help you to interact. Right? So the first two interaction diagrams are most important. So as you can see and as you can understand, and at the very beginning, some of you were talking about it, that there may be, you will possibly do a client server kind of model. There'll be different agents which will interact between themselves for the system to execute. So there is a question of what is the sequencing of these activities. For example, I have a login activity. I have a apply leave activity. I have validate balance activity. So in terms of the sequence, the login, only if you log in, then you will be able to go to the apply leave. Right? Login can trigger apply leave. Apply leave, if you try to apply for leave, then you will need to go into the validation of the leave and so on. So what it says that in terms of interactions, the activities will have certain temporal sequencing, temporal ordering, right? So this is in terms of the time order. Now, in many cases, the physical time may not be involved in the sequencing. It may be just the ordering in time, that this has to be done, then this has to be done, then this has to be done, like that. But in some cases, there may be a physical time that, for example, you are doing a kind of a net banking application and you try to transfer a fund, then the system tells you that OTP has been sent to your mobile, and you have to put in that OTP, and then you can proceed. Now, here at this point, so when OTP has been sent, your next activity is validation of the OTP, right? So that validation will be triggered when you put the OTP, right? That is the sequencing. But it has a temporal sequencing also. Alternately, the system will also count that if it is, say, 60 seconds or 120 seconds from the time you are shown the message or from the time the OTP is sent, if you do not put it, then the system will trigger a different activity, right? So there could be certain sequencing which are actually based on the clock, but in general, the sequence diagram talks about the temporal sequencing of the activities without reference to a physical clock. The similar interaction in terms of space is known as a communication diagram. So in communication diagram, what you say, like in sequence diagram, you are talking about what activity is triggering which activity, and if you complete an activity, what is the activity you go back to, and so on. But in communication diagram, you are saying which agent or which subcomponent is interacting with which subcomponent. So there is a subcomponent for leave accounting, there's a subcomponent for approval, there's a subcomponent for joining. So the interaction between these components is what is captured in the communication diagram. So kind of sequence diagram tries to capture a temporal view of the system, whereas the communication diagram tries to capture a more spatial view of the system. Right? So those are the two primary kinds of interaction diagram. Then you have a timing diagram. Timing diagram, for example, for a system like UML, for a system like LMS, we will not have a meaningful timing diagram, but systems which are driven by strong timing information. For example, if you have already done digital design, computer organization, and so on. So, for example, when a processor works, then there is a basic clock, and with the clock cycles, there is specific things that happen for different instructions that are executing. So the timing diagram is primarily with respect to systems which are driven by a real-time clock. And UML, as I said, UML is not limited to just,
Sir, you are muted. Sir, you're not audible, sir.
Am I audible now?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
How did I become muted suddenly?
Yes, sir.
So, in terms of the different diagrams, I have stated in brief as to what that diagram does. This is just to get an overview of the overall UML, right? So, I'm skipping these details. This is exactly what I discussed right now. Let me move on to basically discussing, relating these diagrams now to the SDLC phases. Right? So these are the phases that we have talked about: requirement specification, analysis, design, implementation, test, deployment, and maintenance. Again, I've drawn this in a linear manner fashion. But that does not mean that this is based on waterfall. These are the sequencing of activities in software development that needs to be done, but we have seen in SDLC that they can be sequenced or iterated in multiple different ways. But always there is certainly a forward flow, and on review things are not okay, then there's a backward flow to the previous SDLC phase. So even from maintenance, you can propagate back to the requirement specification. So our intention is, so on one side we are saying that there are a number of powerful UML diagrams available, and on the other side we have an overall view of how the system will be developed, or what is the life cycle of that software. So now we would like to relate these two. I'd like to map the UML diagrams onto the different SDLC phases. Right? So the first is to split the SDLC into, you could say that pre-implementation and post-implementation kind of phase. So the requirements analysis, specification, analysis, and design are the three stages where object-oriented system design gets heavily involved. Right. So these are the stages where we will see that a large number of UML diagrams will primarily relate to these stages. We will come to details, but just at a top level. The remaining part, implementation, test, deployment, etc., are system implementation using object-oriented programming, right? Because the system has already been analyzed and designed. So now you need tools of programming, whether in terms of just a C++ kind of language, or in addition, for example, for testing, you may have for this, scripting language, which are object-based, and so on and so forth. But this is how the overall life cycle will go. So now we go into every specific phase in SDLC one by one and try to relate the UML models to that. Okay. So again, all these descriptions are actually in terms of the UML diagram itself. Okay. So I will explain what these symbols mean. So there are three basic actions to be taken in the specification phase. One is to construct the use case model. That is the primary capture of the requirement specification. Two is to construct the problem domain model. Problem domain model is bringing the use case down to the specific domain in which, for example, here we are talking about leave management system. So it's in terms of the specific domain that you come in. And the third is to construct the interface model. How will the system interact with the user? So typically talks about user interfaces and things like that. Right. So this blue, rounded corner rectangles tell you what are the activities. and the white boxes are what are the outcomes. So if you do this activity of constructing use case model, what you come out with is use case model. Now, then it looks like a flow diagram, kind of flow chart. So you have from the top bar three pointed arrows going to the three activities of constructing use case model, problem domain model, and interface model. And then again, three arrows coming and joining at this lower bar. So this is a way to kind of define the conditions in the system. In a flow chart, we typically go sequential. Right? We just have one path. But
sorry, at least in my screen, your slides are frozen. I don't know, is it true for others also or not?
I'm on slide 7. Are you seeing slide 7 or?
No, slide 6. In my screen at least. It may be problem with my system also.
Sir, I can see slide 7.
Okay, then maybe it's a problem in my system. Please continue. Oh, sorry, very sorry for it.
No. It says today some of the system is in bad mode. Okay, so now in a typical flow chart, it is a sequential, but here it is kind of precondition post-condition model, which it says, for example, I can proceed beyond the requirement specification phase provided all the three activities have been completed. Right? That is, use case model has been constructed, problem domain model has been constructed, and interface model has been constructed. So this bar is a trigger point where only if all the three completions have come, or so to say, all the three controls have arrived, only then you can proceed further. So in kind of concurrency terms, you can say that the bar on top is fork, that you fork out and do these activities, and bar on bottom is the job. It's this notation is typically derived from the Petrinet model, and it's is a part of the UML diagram. And after that, you have a diamond here at the bottom, so which is a condition check typical of the flowchart. So if there is no further use case to capture, then this phase is over. But if there is further use case to capture, then you go back to the top and start doing it again. That's the basic idea. And we will use this, this modeling style in every phase. So let us see out of this what will come out. What will be the output? Okay. So the intended output are requirements model. Okay. And again, as I said, that this itself is expressed in terms of UML. So let us understand the symbol a little bit. This, diamond, open diamond means composition. Right? So it says that requirements model is composed of a number of use case models. Right? Now, the multiplicity of composition as to how many models will be there is denoted by the number here. So it says that the requirement model, so if I read it out in English, it says the requirement model must have the use case model, one use case model, one problem domain model, and one interface model. Okay. Now, in the use case model, you will have use case diagram, and you will have descriptions of the use cases, which I mentioned at the annotations. So it's just not it's just not that you draw an ellipse and write applied leaf. You put small annotated description to that for human understanding. And you can see that on the multiplicity side, there is a star given. The star is the same symbol as you use in the linear closure, which means that there could be 0 or any number of description of use cases. So use case models will come in terms of use case diagram. Problem domain model will come in terms of the class diagram, right? So you are bringing it down to specific, members and details of the classes. So that comes under the class diagram. Interface model come in terms of user interface specification and the system interface specification. There could be many of them. This is one area where till date UML is not very powerful. So you'll see that I've colored certain boxes. That colored box mean that it is a diagram of the standard. So it has standard notations and so on. And other ones are white. That means that they are still in terms of open mode of specification, that is English description, writing up things and so on. So user interface still, a lot of work has been done, but still there is no standardization in terms of the user interfaces in UML expression. Right? So this is what the requirements specification phase will produce. Then there will be the analysis phase. So in the user requirement, in the requirement specification phase, we have got the use case model, the problem domain model, and the user interfaces. Of these, naturally, the use case model gets frozen in the requirement specification phase itself, because that is the time when you are directly interacting with the customer to get the details. But it is the problem domain model which you keep on working further through the analysis. So you refine the problem domain model. And as you refine that, you will construct the structure model. What are the structural aspects of the problem domain? And you will construct the behavioral model, because just recall that problem domain model per se was talking about classes. So a lot of the behavioral stuff may not be, for example, sequencing, all that may not be there. So that will produce the behavioral models. So a structural model constructed, behavioral model constructed. This is what you are doing in the analysis phase. And you keep on iterating as long as, requirements, further requirements are there. And when there is no further requirement, you terminate. So at the end of analysis phase, this is what you have. You have analysis models. You have structure model and you have behavioral model. For the structure model, you have the UML class diagram. But mind you, because of the refinement, the class diagram may have got refined from what you did in the requirement specification. For example, in the requirement specification, possibly you could not specify the different visibility aspects of the members. You possibly could not decide whether an attribute is primary or is derived. For example, what I mean by derived is, suppose for different logic that I have to implement, I need the age of an employee. Right? Now, age of an employee, therefore, is an attribute of the employee. But you cannot keep the age of an employee as an attribute in the class as a data member, because if you keep that, it changes every time, right? So what you keep is a date of birth. Right? And age then becomes an attribute which is derived from the date of birth on a need basis. Right? So these are called derived attributes, that you have an attribute to which you cannot directly have a value for, but you can derive their value whenever required based on the other attributes. Okay? So in that way, the class diagram may have got further refined. And on the behavioral side, you have the sequence diagram, collaboration diagram, state chart, and activity diagram. As I said, that I'm talking primarily about kind of application software development aspects. So things like timing diagram I've skipped. Because if you do a timing intensive activity, then you'll have to have those as well. So for us, what is important is the structure in terms of the classes, sequencing of the activities themselves, the temporal sequencing of the activities, interactions and collaborations between different agents, and the state transitions in the system. Okay? This is the overall analysis that we do, and this is where we will get to. Once this is done, then the next SDLC phase will talk about design. So this is again an iteration between the system design and detailed design. As input, you have all these 5 diagrams and user interface, UI information if you really want. And from there, you do a system level design to produce a high level design model, which goes into the detailed design to produce a low level design. So that's a refinement. What you call high level, what you call low level is somewhat, the line is not very sharp, but kind of it is taken in this way that a high level design is something where the design process can be frozen and low level design details can be done, which can be directly handed over to the developer for coding. But high level we'll see some examples of that, but high level will basically, for example, in terms of the classes, the high level design will typically mean that you have you have the interface of the class, you have the different decisions about the visibility of the decisions, about the lifetime of the objects and so on. You have possibly the identification of the broad strategies. But when you come to low level design, you may talk additionally about, well, what is what are the different containers you will use from STL, what are the specific algorithms that you will be engaged in this, and so on. Right. So now it pretty much somewhat is subjective. There's a broad sense of things, but if I may say so that well, if a high level design is of 4 pages of code and pseudocode, a low level design possibly is 20 pages of that. And then you keep on iterating through it till you converge that there is no further requirements that are necessary. So this output is the design model, which are structural and behavioral models that you already had from the analysis phase, and you have only refined them. Right? So these models, further details of those are not shown, but they are like the analysis phase, 5 different diagrams. In addition to that, you have now the component diagram. You have decided on the specific components, which is a structural aspect. And possibly you have decided on the deployment strategy, which is given in terms of the deployment diagram. And you have an architectural description. This again another area. It is white. So this is again another area where UML still does not have a very well-defined standard diagram. So it's still in terms of generic drawing and description. So that is kind of the object-oriented analysis and design applied to the SDLC phases. And the other phases, implementation, test, deployment, maintenance, these will be done using various object-oriented languages, and some models will continue to be used. So let us stop here. We lost quite some time today. So let me check if there are any questions or comments.
So when we talk about maintenance of the software, what exactly do we mean?
Maintenance of the software will mean that you have developed, you have tested, and you have given it to the customer. It has been deployed in the customer's own network and systems, and then the customer comes back and says that, well, in this case it is not working. That is not supposed to happen. And well, if I have the provisions done for joining, I've done the provisions done for termination, but here is an employee who is not terminated but is superannuating, retiring. Your system does not take care of that. So you have to then go back and make changes to the system. So maintenance could involve primarily two kinds of activities. One are which are known as bugs. That is something which you are supposed to provide, and you have provided is not behaving the way it is specified. That is a bug. The other is what is known as enhancement. That even after doing all this, what you understood and what was possibly meant by the customer, there's a gap. There are certain things which got missed out. For example, the superannuation case I just mentioned is a kind of enhancement. Like the customer thought that obviously, since you can fire an employee, so the termination will also have other conditions of ending the employment, but you didn't think so. So maintenance is an activity which involves bug fixing and enhancement for sorry, I had lost again. So as I was saying, the maintenance involves both of these activities, the bug fixing as well as enhancement, depending on what you have contracted. You may have contracted for small enhancements only. And maybe if there's a big enhancement, then it will probably have to come in. For example, the company decides to do a organizational change, brings in a couple of other types of employees and responsibilities. Then that enhancement, obviously, possibly you will have to separately contract for, and you will not call it a maintenance, you will call it a reversioning of the system. Okay. Does that answer your question? I missed the name of who I had asked.
Yes, sir.
Any other question? No. Okay. Okay then. So let us close here today. We will continue in the next week. Have a nice day.